Hello. In this set of tutorials, I'll explain how to simulate different power electronic circuits in Simulink. So let's get started. This is the very first tutorial, and I have opened the Matlab window. Here's the Simulink. You can either click right away, or you can type in here in the command window Simulink and press enter. So here you get some options. You can open existing examples where you can learn operation of the different toolboxes, or you can start with a blank one. We'll start with this blank model. Once a blank model is created, you need a library browser to drag and drop components, and then we'll connect so that we can run it. So here is the library browser. We can just press, and you normally get this kind of view when you first open the library browser. The important components that we need will lie under the Simulink library. Sometimes we need sources, and one of the important one is the scope. This is something that we'll need. And then when it comes to the circuit components regarding the circuits, we need Simscape. In Simscape, further the electrical, and then we get into the specialized power system. So we'll use this library, the specialized power system library, to create our power electronic circuits. And we can explore the sub-libraries. We can go to sources. Here we can add the AC or DC sources, voltage or current source, of course. And then we have the power electronics. Power electronics components like MOSFETs and diodes and half bridge and full bridge, things like that. Even three-phase bridge we can create. And the way to add a component is just by right-clicking, and then we can use this option, add block to the model. Since the new model is named as untitled at the moment, we haven't saved it, so it is named as untitled. So if you save it, the untitled will be replaced with the name you use for saving. You can also find the help document. At the moment we are not interested. So in this very first tutorial, I would like to create a half wave rectifier, and for that, of course, we need a diode, and I can drag and drop here like this. With the mouse scroll, I can zoom in or zoom out. Similarly, I'll go for the AC source. Here are the sources, and I'll go for the AC voltage source. Drag and drop. Alright, similarly we can go for I need a passive component. For example, I would like to add a resistor. Here we have series RLC branch. I'll drag and drop here and double click. Here we have different options like RLC. I have R, RL. I'll just choose R and we'll set some value, let's say 5 ohm. Okay, and now I can rotate this resistance. I need to select and press Ctrl R, and it will rotate by 90 degree. All right, now I can just connect. Have a look. The square terminal, as you can see, it will connect with the square terminal of the other component. Similarly, this will go here, this is going to connect here, and this is going to connect here. Okay, now notice that I cannot connect this terminal here. The reason is that the type is not the same. I mean, this is the path in which the current flows in the circuit, and that is the measurement port, and we can read this signal on scope. So one more way to add a component is you can just double click anywhere and you can type in the name of the component you are looking for. So for instance, I'm looking for the scope. I'll just double click and it finds the scope in the library and just add it here. Similarly, I need a measurement, a component for measurement, and I'll get to sensors and measurement. Here we have this multimeter option. I'll drag and drop here. Alright, so now what I'm looking for here is that the voltage across this resistor, and I'll enable here the branch voltage and current. So when it is enabled, and okay, let's just set the values first. Here's just the input. It's a peak value of 100 volt, and let me set this to, for instance, 50, and I'll set this to voltage. This means that the measurement means that what kind of signal I'm going to record. Like in the measurement blocks, I'll be able to measure this this signal if it is enabled. If if it is selected to none, if it is set to none, we cannot measure it here. We'll need something else like voltmeter or something. But if we are interested to measure it without any physical connection, then we need to set it to voltage. Similarly, I set this to branch voltage and current, and for this very same reason that I'm interested to record the voltage and current of this resistor over here in this multimeter. Okay. Now, before running this simulation, we need to set up the stop time, and for keeping the frequency in view, here we have 50 Hertz frequency. 1 second is more than enough. We'll get sufficient number of cycles, so we'll just set this to 1, and let me just quickly run it, and I want to show you that there is an important block that is missing in this simulation that we need to add. Yeah, so you'll get this error if you do not add what we call power GUI. So this is something you need to place in every simulation, and we'll explore in the upcoming tutorials that the different jobs that Power GUI offers. Here are the different tools that we can use. So for the moment, I'll just get rid of it, and I'll run again. So have a look at the bottom, and okay. Now this means that the simulation has been completed, but the thing is I haven't selected any signal. So I need to select the signal that I want to display, that I want to add in this multimeter, and that will be, of course, displayed in the scope. So let me add the source voltage, and then this is the voltage across the load, and then the source voltage. This is source voltage, USRC for source, UB is for okay. So let me close this, and keep it in mind that the scope, the result will not be updated on the scope unless we run it again, because the signals were not there previously. So now I'm going to run it again, and here we have our result. Okay, so here in the top we got option, auto scale option, and sorry, here is it. I would like to go for the x-axis zoom so that I can select few cycles, and have a look. This is the half wave rectifier, and the yellow one shows the output voltage, and the blue one shows the input voltage. But have a look that it doesn't look sinusoidal, that the shape doesn't look like sinusoid, and the reason is that we haven't set the right parameters in the simulation configuration. So here's the so here are the options that gives us flexibility. One of these options is let me just set it to fixed step size, and let me just set this to 1e-5. This is the fixed step size that I'm going to set. I'm going to apply okay, and let me run this program again. Okay, now have a look. Things have changed after I switched to the fixed step size, and I set a relatively low step size. So the lower is the step size, more accurate result you get. But the problem is you cannot keep the step size much lower. Let me give you a reason behind this. Let me just set this step size to e⁻⁹, for instance. What it means is that it will process a new sample up after 1 nanosecond. So this means that the number of samples will increase, and it will this 1 second simulation times will take much longer to simulate. And have a look at the bottom. We are just at 0%, and have a look, the simulation is going on, and we are just at a few milliseconds. So although we'll get a much accurate result, but sometimes this much accuracy is not required. So we need to smartly choose this step size in order to reduce the simulation time and get adequate accuracy. Okay, so now we have a look here. Have a look at the progress. It's done in no time, and the result is quite good. Okay, so this is how we can run simple half wave rectifier in Simulink.